Hello guys, welcome to our virtual classroom. Uh, this is the way I'm proposing to do the lessons for the time being for the following 2 weeks. And guys, you will hear me and you will see everything that I'm writing here as on the whiteboard. And guys, we have some things to talk about. I'd encourage you to use your notebooks and take some notes, as well as take your regular textbook, because there are some illustrations that I will be talking about. So even if you're not Polish speaking, you might still use some of them. And guys, it's time for us to finish the topic that we had recently uh, about food chains and food webs. And guys, I cannot remember. I think that we haven't finished it last week or 2 weeks ago. I can't really remember. Uh, when we were talking about food chains and food webs, food chains and food chain looks like this. Here we have the producer, then we have the primary consumer, then we have the secondary consumer, something, something, something. Then we have the decomposer. We have been talking about food webs, which basically look like this: producer, primary consumer, primary consumer. But this primary consumer is also a prey to secondary consumer. But the secondary consumer can also, if it's omnivorous, can eat the producer, which is in this case plant, and above all of this, and it can basically work in many directions, and all of them are being distracted in the end by decomposers. So this is more what it looks like in reality. And guys, those relations between the species are need to be held in balance. This is the so-called the dynamic balance uh, of a stable ecosystem. And basically it works pretty well if circumstances aren't changed. But sometimes it might happen that a new species will be introduced. That means that it might be brought by humans, or something will happen to the environment that will change the whole ecosystem, so some of the species will disappear. And this is the second case when we have a lack of a certain species. And this is what happens if we have a lack of certain species. For instance, this consumer disappears, then the whole part stops to exist. If it stops to exist, then we have a huge disruption to the whole dynamic balance, and this is how ecosystem collapse. Uh, and now, guys, as you can see, this is here and here. It's all in circles. It's all constantly circulating. Do you know this equation? This is the very famous formula popularized and associated with Einstein. And this means like more or less this: energy equals mass times speed of light squared. And guys, this states that energy can be in a few forms, can be present in a few forms, including mass times the speed of light, which means that energy and matter are almost the same, but in different forms. And guys, today we're going to talk about matter and energy. Uh, and they are really important in terms of whole ecosystems. And the first thing that I'm going to talk about right now is the circulation of matter. And we have to treat it in a very literal way. That means we have a plant, and the plant is growing, and it's built of literal matter, right? Because it contains some chemical compounds, some chemical elements, it's phosphorus, it's carbon, it's oxygen, those are particles of water, and stuff like this. Those are physical atoms, those are physical particles. And guys, a caterpillar starts to feed, this was supposed to be a smile. A caterpillar starts to feed on those leaves and starts to destroy them piece by piece. What it does, it digests the plant tissue, which means it's breaking inside its digestive system, it's breaking the leaf into a bunch, a cocktail of chemical elements and chemical compounds. This caterpillar is using this those chemicals in order to build its body. So it rearranges physical particles. For instance, calcium, phosphorus, it also rearranges carbon, oxygen, nitrogen, all the chemicals needed in order to transform itself after some time in a form of a butterfly, right? So this butterfly is totally, entirely made of chemicals that once were present in the plant. And basically, if it comes to butterflies, their life is simple. They start as eggs, then they hatch, then they are caterpillars, then they transform into the adult form, which is the butterfly itself. And the only task that a butterfly has is to reproduce. And that's it. Some of the species of butterflies, if it comes to the males, they are born without mouths, so they are not supposed to feed themselves. They are just supposed to here to find a mate, then breed, reproduce, and that's it. And they die. And once it dies, all the chemicals that were present in the tissues of the wings and of the abdomen, they are being distracted once again by decomposers. So those are either bacteria, tiny bacteria, or some other microscopic organisms such as fungi, and they are being distracted. And what it means that the chemicals present in the tissues are being once again rearranged. So we have once again a cocktail of chemicals that changes its form, and it changes its form into the form of humus. Humus is don't it's not the same as humus. This is food, and this is the very outermost layer of soil. And this outermost layer of soil is basically crucial for plants and their lives because they do take those chemicals from the soil and transform them once again into their tissues. So we have a very globally thinking, we have a very limited amount of uh, chemicals available, particles, and they constantly change their forms. Sometimes they are being incorporated into animal tissues, sometimes into plant tissues. It changes depending on which place of this whole circle this particular particle is found. So basically, whenever a plant is taking water from the ground, including those mineral salts that are dissolved in this water, uh, it will just rearrange the particles, it will create its tissues, which later on will be eaten by someone else. It can be animal, but it can also be a bacteria. If a plant isn't eaten by anything, sooner or later it will die and will give back uh, the particles that it's taken, it will give it back to the nature. And this is indeed what we call the circulation of matter. This is quite an obvious example, but we have something that is much more subtle, and this is the carbon dioxide circulation. It's also the circulation of matter, although it's a gas. So guys, the very first step that we have is that we have CO2 in our atmosphere, right? As you know, carbon is a chemical element that is absolutely crucial for every form of life. Every form of life needs it. So, carbon dioxide is being taken from the atmosphere by plants, which are producers. Producers take carbon dioxide from the atmosphere. And they do it because they need to perform the process of photosynthesis. And the process of photosynthesis is basically plants take water and carbon dioxide, and in their chloroplasts, with the action of the chemical compound called chlorophyll, and under the presence of sunlight, they transform those two compounds into oxygen and energy. And guys, this is the moment where they take this carbon and later on it's being used to gain some energy. But once the plant is eaten, then we can be the consumers. So we eat a salad, for instance. So we are ingesting this carbon that the salad has inside of its leaves already, and we are giving it back to the atmosphere because we breathe with oxygen and we exhale carbon dioxide. So consumers get rid of CO2, and we get rid of it directly into the atmosphere. But also breathing. This is in the process of breathing. But sometimes the consumers will just get eaten and decomposed. Decomposers, they also breathe. So they also give it back to the atmosphere. So guys, this is breathing. Here it will be photosynthesis. So as you can see, it's constantly changing. And guys, you know this symbol, right? Where we have this arrow. Why is it like straight? Whatever. So we have this, and we have this. Oh my god, it's so ugly. Ah, whatever. Guys, this means that an item can be recycled, and this recycling, this whole symbol was taken directly from the fact that the matter is constantly circulating in our world. Some of the matter that we can use can be recycled almost all the time. For instance, aluminium can be recycled hundreds of thousands of times and it will not lose its properties. Paper can be also recycled many times. The same thing applies to basically to glass. Some of the materials are difficult to recycle. For instance, some types of plastic, so they are good for recycling. For instance, styropian, cannot be recycled. It's almost impossible. So this is why we should opt for materials that can be recycled. But guys, as we said, energy, matter is only a different form of energy. And guys, where do we on Earth get energy from? The answer is simple. It's the big nuclear reactor that is shining above our heads, and this is the sun. Thanks to the sun, we are able to live here. And most of the energy that comes to our planet comes as a form of insolation. Insolation, which means the amount of energy, solar energy, reaching surface of Earth as a short wave radiation. And guys, plants, of course, use this energy in order to grow, right? They need photosynthesis. We said that they need carbon dioxide, but also they need photosynthesis. So they take this energy and they take parts of it in order to create their tissues, right? And guys, then this energy that we have from eating those plants is exactly the same energy that arrived to the planet from the universe. And guys, then we have primary consumer, then we have secondary consumer, then we have something, and in the end, we have the decomposer. And guys, here they use about 10% of the energy that they receive. Here it's getting less and less energy. So the decomposers have the least of the energy that was initially in here. And guys, it's very important to know, you should know this from physics, that energy, why did I do a typo while writing with my hand? I cannot understand it. Never mind. Energy, once again, oh hell no. energy cannot be added or destroyed. And that's very important because energy simply is. There are various theories on where does energy come from, but this is the most important statement. Energy cannot be added or destroyed. So here it makes sense. Guys, and this is the process of energy. Once again, seriously, energy flow. And guys, those two processes, energy flow and matter circulation, are the two most important processes that shape the way the world looks. And guys, energy flow refers to energy as a somehow abstractive construct, and matter is that literally matter. So I'm speaking of atoms, I'm speaking of uh, particles. Guys, that's it for now. And according to what I can see here, we should be having a test, and I have no idea how to solve this for the time being, but I guess I will come up with something soon. So thanks for attention and enjoy your day.